Another look at particle motion. So another look at our physics aspect of position, velocity, and acceleration.
Ocean tomatoes.
Okay. Thanks.
Not you. The lady's name.
That's part of the calculus curriculum. You can't blame her. So,
Calculus.
okay. So, it's topic 8.2, connecting position, velocity, acceleration functions using integrals. So, we talked much about our physics aspects since this semester, since we've done integrals. Maybe a little bit in Unit 6, but really we are talking more about them with derivatives. So now we're looking more at them with integrals, okay? So, particle motion problems deal with motion along a straight line. This includes horizontal and vertical motion of a falling object. It's important to note that the motion meant the particle was moving along an axis, not along the graph of the function. Now it is possible for us to work in two directions. For example, if an object is traveling in a straight line, then its velocity can be expressed as the integral of acceleration. Now we'll focus on getting a better understanding for how to model motion problems that will appear on the AP Calculus exam. Okay, so net change theorem. The definite integral of the rate of change of a quantity, f prime of x, gives the total change or net change in that quantity on the interval. So kind of what we talked about here, or in that homework problem we just did. Okay, kind of a good lead in here. That the integral from a to b of capital F prime of x, well, if you integrate that derivative, you get just capital F, yes? And then when you plug it, you're plugging in your values, it's f of b minus f of a. So when we talk about the integral of the rate of change, so integral of a derivative, then it's going to be the total change, or what I feel like you hear more is net change. Okay, so keep that in mind here. Now, they share with us three main question steps. Okay, and then after that, we're basically going to go through, if I recall, just different examples, different scenarios, but different options here. Okay, when given an object's velocity and a question stem is asking about the object's position, we need to understand which definite integral is necessary to respond to the prompt accurately. Okay, so as we look at this first one, the displacement on A to B. So if we are talking about displacement, okay, in order to find displacement, realize that, excuse me, you are integrating velocity over the interval, okay? In a scenario like this, when you're looking at the graph, okay, as we're looking at displacement, we know that A1 and sections A1 and A3 have a positive value because they are above the x-axis. A2 has a negative value because it is below the x-axis. And so when we're talking about this being a velocity graph there, we're talking about adding A1 and A3 and subtracting A2. Okay, that's what I thought. There is. So I'm gonna relate it down to here, where we have this example here. Given that S of 0 is 4, find displacement, total distance traveled, and position on 0 to 10, where V of t is in meters per second. So if we start with displacement here, okay, what are we looking at here? We're going to have, and I'm just going to kind of squeeze it in here, the displacement, okay, so the integral of V of t, which V of t just represents that graph. What interval?
0 to 10.
Okay, we have a starting point of 0, an ending point of 10. We don't have V of t to integrate, so we're looking at that graph. How are we going to do that?
18 minus 12.
Okay, remember when we think integral, we're thinking that area under the curve. So 18 minus 12, which is 6. Okay. Okay, which is not exactly. What is our label there?
Just say units.
Meters.
Oh, meters per second. Because we integrated and we're going from velocity to
Yeah. Velocity is meters per second. We just integrated velocity. When you integrate velocity, you're going back to position. When we talk about displacement, displacement is a distance. And so the meters here tells me to use meters, but it's not the meters per second. Okay? So that would be our displacement. Okay? We can also talk total distance. Okay? When we talk total distance traveled on A to B, again, based on this graph, the change is that we are doing the absolute value. Okay? Because total distance, displacement is just, you guys remember this? If I go forward, farther, backward, displacement is just the distance from where I started to where I stopped. Whereas total distance is, I'm adding all the movements up. Doesn't matter if I was going in a positive direction or negative direction, I'm adding all the movements up. And so that's where you see the absolute value. So if we're looking at ours, still the integral from 0 to 10 of the absolute value of v of t dt. What's that change going to mean for us? Yeah, 18 plus 12, which is 30. 30 what? Meters. It is a distance. It was integrating velocity again. So for both reasons, it is meters.
I have a question.
Yes.
Not about this even. About last one, about the test. Did you have us do was it an assignment? Because I did some of them. I'm sorry. I was just starting.
Did I have you do what?
Have them turn it in.
No, I didn't have them turn them in.
Okay.
I had them.
'Cause I didn't do 2 of them, but I did all the others.
Okay, no, but I just ended up checking the worksheet. She's taking it today. Yeah.
Because I can get it done. I'm gonna take time.
Okay. Last one. Position. Okay, that was total distance. This is going to be position on 0 to 10. Okay, where v of t equals, so position, now when we talk about position, this is the key thing here is taking into, did they give us a starting position? And they did. What'd they say our initial position was? They said that at time 0, we're already 4 meters from the beginning, or whatever the case is. So that right there is your C. That is your initial condition there. So then that means, in my case, I'm looking at 4 plus the integral from 0 to 10 of v of t dt, which is going to be
6 plus 4.
4 plus the 6 I got earlier, which is indeed 10. Okay, so that's your, when we talk about position, that is your starting position plus your displacement. Okay? So those are pieces, just, that's a good reference piece of, okay, how do we find each of those vocabulary words? Displacement, total distance, and positions.
I never understood them.
Well, you get another chance today. Okay, number 1. The graph at the right represents what? Velocity. Always make note of that in your brain, on the paper, something. What kind of graph is it? Because that makes a big difference, right? The graph at the right represents velocity of a particle that is moving along the x-axis on the interval from 0 to 8. Notice my x-axis goes 0, or my graph goes from 0 to 8 on the x-axis. And v of t is measured in inches per second. Okay. So A, for what interval or intervals of time is the particle moving to the right? And justify your answer.
0 to 3 and 8.
So when is the particle moving to the right?
When it's positive.
When what's positive?
The graph.
What is the graph
Velocity.
representing? Velocity. Yes? I know you guys can see its velocity, but I'm trying to get you to state it, okay? So my answer here says when velocity is greater than 0, particle moves right. That's kind of I guess I'm doing my justify first. And you guys said from 0 to 3 and is it 7 to 8? Okay.
Do we have an equal to on the 8? Yeah.
Possibly. I'm trying to think. I do not have an equal sign on mine in my notes. And I'm trying to think how much it would matter. Because as weird as it sounds, there are times it matters whether or not you put that equals piece. And there are times where it doesn't really matter. I kind of feel like this might be one of those times where it doesn't really matter.
Yeah.
But I do not have one on mine. Is that a fair enough answer?
Yeah.
Sorry, that's the answer. I honestly am not 100% sure if you can get away, but based on what I've seen with grading pieces, so. Okay, now that was moving to the right. Now the question changes. On what interval is the particle slowing down?
2 to 4. Wait. 2 to 3. 6 to 7.
What do we remember here?
Not a lot.
That was right. Positive.
Oh, yeah.
Okay, so the whole speeding up and slowing down thing, okay, is all about signs. So we're being asked for slowing down, which means we are looking for opposite signs between our velocity and our acceleration. Okay, so
2 to 3 and 6 to 7.
I'm going to go ahead and write that. When V of t and A of t have different or opposite signs, the particle is slowing down.
Not to be picky about grammar, but it's how, not has.
No, you're being picky about it.
It does
Okay. In my defense, at the time I wrote it, I had proper grammar because I did have hat. Today, I don't have proper grammar, I guess. So, and
No.
I will say that and joke about that. But should I still have proper grammar as a teacher and an example?
It does.
I should, but
We
I also am
well,
much better about my math rules than my grammar rules. So, okay. Good news is I think you could still get away with using has instead of have on the AP. I don't think they care. Might not, it's math teachers grading it, not English teachers. Although I will say I'm probably much more lax than some about, complete sentences and grammar and all of that. So, okay, so we talk about different signs. So, velocity, this is a velocity graph. So, up above, velocity is positive, yes? I need to know when is, in any of these places, when is acceleration negative? Well, how do we find acceleration? Acceleration is going to be the slope because acceleration is the derivative of velocity. Sound familiar? So if I have positive velocity, do I have any negative acceleration or negative derivative? And that is happening between 2 and 3. Okay, so on that one, I'm going to say where, what is it? V of t is greater than 0 and A of t is less than 0. So that's positive velocity, negative acceleration. And that's on the interval 2 less than t less than 3. And when, now we need to talk the opposite, right? When V of t is negative and A of t is positive. So velocity being negative is down below. Where is my acceleration positive? 6 to 7. Because my velocity is negative, being down below the x-axis, acceleration, I have a positive slope. And so that is on the interval 6 less than t less than 7. And we can say the particle is slow. Particle is slowing down. Okay, so we're bringing back some of these rules, right? Okay. Okay. I was just trying to read what I wrote in here in my notes, but off to the side I kind of wrote an asterisk and I wrote graph is decreasing above the x-axis or graph is increasing below the x-axis, which if you need to write something down for yourself for later, you can. Okay. When is the particle stopped and changing directions? So what are we coming up with? 3 and 7?
Yeah.
Why 3 and 7?
It's changing from positive to
Okay. First of all, velocity is 0. So velocity being 0 would indicate that our particle is stopped. And then what's the other thing we have to talk about? Changing directions. Changing directions happens when, velocity changes from either positive to negative or negative to positive. Okay? I think, the 0 thrown out there, but that's stopped. But we don't have a changing condition or a changing direction. Okay? So, how do I want to say this? V of t equals 0. And I don't even think I said the other part. Okay, when V of t equals 0 and V of t changes sign is what I'm going to say. Changes signs. V of t equals 0 and V of t changes signs. The particle stops and changes directions. And that is at t equals 3 and 7. Okay. One more on this one. What time interval is the acceleration 0?
1 to 2.
Okay, and what has to be true there?
So it has to be 0.
Okay, slope has to be 0. And you can also talk about the velocity has to be constant. Okay, I have both written in my notes when the velocity is constant and a of t equals 0. When velocity is constant, I guess justify, you can't really say a of t equals 0 as a justification. It's when velocity is constant, a of t equals 0 at, what did we say? Or what did you say? 1 to 2 and 4 to 6. Okay. So that's a graph for you. Are you going to see graphs on the AP?
Yes.
You will. Okay, whether it be in free response, whether it be in multiple choice, you will see graphs. There's just no getting around it. Okay. Just like you will see graphs, you will also see tables. Okay. So let's look at this table and see what it gives us. The city bus accelerates as it leaves one stop, then decelerates as it comes to another stop. The chart below measures the velocity v given in miles per hour between each stop. So we have a 3-piece chart here. We have time provided in minutes. We have velocity provided in miles per hour. And we have to fill in the distance. Okay. And then I think we need to fill in the distance before we do A and B, right? Oh, okay. I guess A is find the distance in miles the bus travels between every interval or stop using the trapezoid rule. Okay? So we'll do an example here, and then we can apply it. You can sub in the other numbers to apply it here.
1 0.
But I don't want to use a 0. I don't want to use a 0. I want, Now, first of all,
Jenny.
trapezoid. Review. How do we do area of a trapezoid?
1/2 height, base 1 plus base 2.
I don't know how you write it, but that's how I write it, okay? That's just, we need that review for a moment, don't we? How do we do area of a trapezoid? Because it wants trapezoid rule. Now, I'm going to pick one of our middle pieces to go from, and then we can just kind of change it up as we need to. Okay, so which one does it matter? Let's do from 20 to 25. So my example, because I can't write all these out, right? We're going to go from t equals 20 to t equals 25. Now, with that in mind, okay, we're using our trapezoid rule, right? 1/2 height when we talk about height, height, I shouldn't use the word height. It is the width of the trapezoid, so to speak, right? Because my bases are going to be those two sides going up. What's the width of this trapezoid going to be? Now, what's the catch on this problem?
They're not all 5.
No, because we're going to find them all, but what are we being asked to find the distance in? miles. Okay. Our velocity is in miles per hours. And our time is in minutes. We got a slight issue here, don't we? So your best bet here is going to be to convert and do everything in hours, because it's easier to change minutes to hours than miles per hour to miles per minutes, especially when we're trying to get to miles down here. Does that make sense? So I'm going to use, yes, the 5, because 25 minus 20, right? But it's 5 over 60. I could agree with 1/12, okay? Now, what are the bases?
32 and 4.
The sides, right? The 32 plus 4. And now, you can grab the calculator if you want. You can do whatever.
36.
36, half of 36 is 18. 18 over 12 based on Doug's 1/12. Okay. So this is 1.5. Where's that 1.5 go? In the distance.
In the 25 box.
Okay. Because it's as you travel from 20 to 25, that's going to go in the 25 box. Now, that's an example. You got to do all the rest.
Can we divvy it up again like we did yesterday?
Well, here's an easy one.
0.
0.
That works.
If 0 minutes have passed and 0
That
velocity,
was mine, guys.
okay.
We're all smart.
No, there's still plenty of boxes. There's still plenty of boxes that we can pick from. In fact, there's 7 more boxes. So if we each pick a box, including me,
I picked 25 to 30.
I'm
10 to
doing
20.
the first one, the 5 and the 18 and the 10.
I got 10 to 20.
I have 10 to 6,
Look
5
at
to 10.
30, 40. Did you get 30?
okay.
No, I'm 25 to 30.
So Kylie is 5 to 10. Sophie, what'd you say you were?
25 to
Add another
30.
K. That wouldn't end very well.
I'm
Okay.
34. I was 10 to 20.
Mario, what were you?
34.
Doug, what are you?
10 to 20.
Hannah or Natalie, you want one? 40, 55? You can have the first or the last, Anna. Have you already done the first one? Or you haven't done any of them yet? Okay, I'll give you the first. Of course you were. It's fine.
I have mine. I think
And I guess that means I get that one, right? So I can do my work right here. Now, I do have decimals on my page, just so you know. I assume I did my math right in that. Yay!
I got one from it.
It is. It's
I
one.
got 1.6.
Where are you at? Oh my gosh, these initials are 1.6 repeating.
Yes.
Now, don't just give me 1.6
Well,
then,
yes. That's what I meant. I just got the first.
but I was writing 4 decimal places on here, 1.667 or 1.66, whatever.
For box 20, I got 11.4.
You got what?
11.4.
You got what?
7.
I have no answer above 4 point something
I have 4.
because you're this box. There's one answer bigger than Mario's.
And it's your box. Okay.
Nope.
Nope, it's Natalie's box.
Anna, you said 0.75? I disagree.
What about 3.16 would be?
I can agree with that one. So I have written down 3.1667. Huh? Did you use? I'm trying to think where your mistake would be. Now yours would not be 5/60, so.
You do 15 over 60.
Oh, I
55
saw
times.
You just saw a 0 and a 5 and assumed it was 5, didn't you? Yeah. So yours would become, yeah. What'd you say? Yeah. No, this is why we're all practicing, right? Some of us got to stick with 5 out of 60. Some of us did not. So, okay. Good practice.
I actually put
B.
60 over 100 instead of 10 over 60. That's
Whoa.
what
Don't you just add all those numbers together?
B is find the total distance that the bus traveled in 60 minutes. And yeah, it's going to be adding them all up. I agree. 17 point something.
250.
4. But would you would not 3 decimal pieces, right?
2.251.
250. It's different depending on what you
It depends on what you rounded to. In my notes, I have written 17.2486, and then for whatever reason, I just rounded to 17.25, probably because we're using our rounded pieces, yes? So the 17.2486 would be if we didn't use anything rounded. Does that make sense?
Yes.
Okay. I didn't think we were going to get that final part done, but the power of the calculator.
Instead of taking
Can I take the
trig function